This topic is about linear equations in one variable. The definition of a linear equation is an equation where the exponent on the variable is 1. So something like 2x plus 5 equals 7 would be an example of a linear equation because the variable x has an exponent of 1, even though it's not written there. To solve linear equations, the idea is to isolate the variable by using reverse operations. So to get rid of this plus 5, you would subtract 5 from both sides, for example. The two remarks sort of give you important information about how to go about solving linear equations. So the first remark tells you that addition and subtraction are reverse operations. So to get rid of addition, you subtract. To get rid of subtraction, you add. And multiplication and division are reverse operations. So to get rid of an operation of multiplication, like this 2 that's being multiplied by the x, you would divide by 2. The other remarks tells you the order in which you should go about applying your reverse operations. So usually when you're isolating the variable, you use addition or subtraction first, and then you go on to division to get rid of the multiplication. We'll do plenty of examples, so you should get an idea of how this works as we go. The first example in this topic has us solve the equation 3x plus 2 is equal to 7x minus 10. Remember, our main idea is to use reverse operations to isolate the variable. So we have both a variable term and a number term on each side. So we want to move things around so that our variables are on one side and our numbers are on the other side. So the first thing we're going to do is apply the reverse operation to move this plus 2 over here with his friend negative 10. So let me go ahead and recopy this down here. 3x plus 2 equals 7x minus 10. Now, to get rid of this plus 2, I'm going to go ahead and subtract 2 from both sides. Which leaves me with these guys canceling the 0. Plus 2 minus 2 is 0, so I'm just going to write 3x on the left. On the right, I have 7x. Negative 10 minus 2 is negative 12. But still, I have variable terms on both sides. I have a 3x term and a 7x term, so I have to move those onto the same side. Even though you can't see it, there is a little plus in front of this 7x. So in order to move the 7x to the other side, I'm going to go ahead and subtract 7x from both sides. Okay, so let's talk about the right side first. Positive 7x minus 7x. Those cancel to 0, which means all I'm left with is negative 12 on this side. On the left side, 3x minus 4x, when you collect like terms, you get, 3x minus 7x, when you collect like terms, becomes negative 4x. So now, we still don't have x isolated because, as you see, you have a negative 4 attached to this x by multiplication. This is negative 4 times x. So the final step in isolating x would be to divide both sides by negative 4. Division is the reverse operation of multiplication. So in the end, the negative 4 divided by negative 4 gives you 1x. I won't even write the 1. And negative 12 divided by negative 4 gives you 3. So our final answer is x equals 3. Alright, so here's our next example. We need to solve the equation negative 6x minus 4 equals 2x minus 10. All right, our strategy is going to be to use reverse operations to get our number terms on one side and our variable terms on the other side. So let me go ahead and try to get my numbers all moved to the right. All right? I'll do that by adding 4 to both sides. So here the 4's are going to go away, and I'm going to be left with negative 6x equals 2x minus 6, right? Negative 10 plus 4 collects to give me negative 6. Finally, I need to move my x's over to the other side as well. So I need to move this 2x over to the other side. Because it's a plus 2x right here, right? It's attached by a plus sign that you can't see. I'm going to go ahead and subtract 2x from both sides. Which is going to leave me here with no x's. So on the right, I have negative 6. And then on the left, I have negative 6x minus 2x, which is negative 8x. Okay. Now finally, you see this negative 8 is attached to this x by multiplication. So if I want to isolate the x all by itself, I have to get rid of this times negative 8. So I divide by negative 8. Right? Division is the reverse operation for multiplication. So the negative 8 divided by the negative 8 will give me 1. So I'm left with 1x. I'll just write x. Negative 6 divided by negative 8, that can be reduced. Okay, so let me go ahead and reduce this fraction before I write it on the next line. Right? So first, let's notice that this negative on top and this negative on bottom, when divided, are going to give you a positive. Right, so then that means forget about the signs for a second and just focus on the 6 and the 8. On top, 6 is 2 times 3, and 8 is 2 times 4. So you see they both have a 2 in them, which means you can reduce that 2, and you'll be left altogether with positive 3/4. All right, and that's okay. X is equal to positive 3/4. There's your solution. Okay, so here's our final example for this topic. They give us a monster equation to solve. Negative 10x minus 4 plus 3x equals 2x minus 1 plus 8x minus 3. When each side of the equation is complicated, like in this case, I would go ahead and try to simplify the individual sides first. So for example, on the left side, I can collect this negative 10x and this 3x to give me negative 7x's. And on the right side, I can do a similar thing. The 2x and the 8x get collected to give me 10x's. And also, the negative 1 and the negative 3 get collected to give me negative 4 whole numbers. Now, I haven't actually used any reverse operations or even started to solve this equation. I just simplified each side individually first. Okay, so now let me rewrite where I'm at here with my equation. On the left side, I have a negative 7x minus 4. And then on the right side, I have a 10x minus 4. Okay, so don't forget to bring down this negative 4 right here. Even though we didn't collect him with anybody else, he's still there. He comes down right here. Alright, so now we're back in a situation we're more used to, where we have a number on both sides, an x on both sides, and we have to solve. So I'll apply my first reverse operation, just to add 4 to both sides. So this, on the left side, I end up with negative 7x because my 4's go away. On the right side, my 4's also go away, so I'm left with 10x. Now don't be fooled. At this point, in our solution, we still have x's on both sides. We need to collect those and get those both on the same side. So I'm going to go ahead and move my 10x over to the left side. Again, this is a positive 10x right here. And I'm trying to move it over to the other side, so I'm going to apply my reverse operation. Minus 10x minus 10x. Positive 10x minus 10x leaves me with 0, period. Negative 7x minus 10x leaves me with negative 17. Oops. Let's try that again. Negative 17x's. Now I can apply my division because I have this 17 connected to the x by multiplication. So I'm going to go ahead and divide both sides by negative 17. Negative 17 over negative 17 gives me 1. So I'm left with a single x, and 0 over negative 17 is still 0. If you divide 0 by any non-zero number, it stays 0. So there's our answer.